Saha, and welcome to the Insurtech Story Podcast, the platform to spread knowledge on insurance innovation, digital disruption, and entrepreneurship. Our website, insurtechstory.com, and we are available on Spotify, Apple, and Google. Today, we are going to discuss on a very niche and a very interesting topic that how artificial neural networks unlock insights from unstructured data to benefit insurance. I'm sure all our viewers in the insurance fraternity would be delving into such huge challenge that they face from unstructured data and every set of database that they have. For the podcast, we are delighted to welcome our guest, Niraja Vaidya, who is a machine learning specialist at Aureus Analytics, and she is associated with the company for the past 8 years. At Aureus, she works heavily with deep learning and text analytics. From the academic side, Niraja is a postgraduate in economics and later studied business analytics and intelligence at Indian Institute of Management, Bangalore. So, Niraja, welcome on board, and we are truly excited to have you for this show.
Thanks, Surya. It's great to be here. I'm really excited for the podcast.
Uh, awesome. Would you like to tell our audience a bit on your role at Aureus Analytics?
Yes. So I've been associated with Aureus Analytics for the past 8 years. So I have been working in the data science team as the machine learning specialist. So at Aureus, we deal heavily with insurance companies and insurance agencies. So most of our machine learning problems and data science problems are from the domain of the insurance industry. So typically, every day we kind of build machine learning models and do data science activities with respect to challenges in the insurance industry, like persistency, predicting persistency for an insurance company, or helping them detect which of their policies and customers might have early claims, or detecting fraudulent claims from their claims base. So yes, so that's basically what I do at Aureus.
Yeah, I think the three things that you mentioned right now, it's
Yes.
just perfectly like hitting the right nail in insurance because the sector is currently just focused and the challenges are broadly related to these areas, especially claims and on persistency and data management and so on and so forth. So
Yes.
just to jump into some of the key areas of today's session. Dealing with unstructured data is one of the difficulties that data scientists encounter, right? So,
Yeah.
how do you think artificial neural networks can solve this problem, particularly for the insurance sector? And I would really like, if you can also shed some light on how this artificial neural networks outperform the traditional models that we have, seen or experienced some years back. And some cases, examples from the insurance sector would be a great add-on.
Sure, definitely. So actually, Surya, rather than looking at difficulties in unstructured data, I would say that insurance companies have great opportunities lying in that kind of data, right? So this kind of data has great potential, unstructured data, and it can be really leveraged to make quick and informed decisions in the various processes at insurance companies. So traditionally, insurance companies, when they looked at data, the kind of data they have is some information at policy level. So something like policy number, premium, sum assured, policy type, product type, right? Then you have some information at customer level, like the customer name. Then you might have some information on customer demographics, like age, gender, then customer contact information, then some information maybe on claims, like the claimed date, claimed amount, the settlement amount, right? And more, then again, some supplementary information on agents, on prospects, on products. So typically, when a data scientist or a machine learning engineer looks at this kind of data from an insurance company, what he or she does is we pull this data into a single structure, right? We pull all this information, and what we create is called as input features. So this part
Right.
of building, machine learning models is called as feature engineering. And feature engineering plays a very important role in building machine learning models. So if the features are well defined and if they are relevant to the problem that we are dealing with or the thing that we are predicting, then your model is really robust and the accuracy is also really high. So with this kind of data, which is structured data, right? So policy, customer, you can have all this in kind of relational databases, and these can be easily stored there and again pulled into a structure of rows and columns. And feature engineering there, though it requires some amount of domain knowledge and some coding effort, it is still manageable. But in addition to this traditional data, nowadays due to advancement in technology, what insurance companies also have is some different kind of data. So if I were to take the example of say auto insurance, whenever a customer submits a claim for damaged car due to some accident, right? He or she is required to send a photograph, right? So the insurance company must be having thousands, and I'm sure much more than thousands, so lakhs and crores of photos of cars, right? Then
Right.
similarly for life insurance or mediclaim companies, they must be having a lot of medical imaging, so X-rays and MRI scans. So images in that domain. Then you might have certain videos of certain incidents or accidents, or even for that matter, while dealing with customer feedback. Right now in the industry, the world today is a world of social media. So especially the younger generation today has to convey anything to the company, they'll just go on Twitter and maybe tweet. Or if
Correct.
the
Yeah.
company, yeah, puts some notice or put some information on social media, then there are not just customers, but there are the general public opinion they can find in the comments, right? Or even in the traditional, if you look at the traditional method, so you have customers calling up on call centers, registering their complaints, giving their feedback, or sending emails. So all this data, if you see, is not in the form of numbers or not in the form of very clean and very well structured fields, right? It's in the form of images, videos, audios, and text data, free text. So all this combined we call as unstructured data. And while this unstructured data has huge potential, there is some difficulty as well in dealing with this kind of data, right? So, and the difficulty lies in the process that I mentioned earlier, which is feature engineering. Because you can't use an image, if I were to take the example of auto insurance again, you cannot use the image as it is in any data science problem that you have to solve. For example, if I want to say detect the damage to the car in the form of say dents or scratches, if I want to detect from the image, you can't give the image as it is as an input feature. You will need to define input features from that image, and an image is nothing but a bunch of pixel values, right? So if I were to manually define which pixel values out of that image are important in detecting the dents or the scratches, or if I were to define these features, then it is a very I'll say a very tedious and a difficult process, and most of the times I'll not be accurate as well, right? So where ANN or artificial neural networks help is this process of feature engineering or detecting input features is automated, or it's a part of the algorithm. So I don't have to make the input features and supply to the algorithm like we do in the traditional machine learning models, right? So it detects the important features, or it detects what combination of pixel values are will be important in this particular problem of detecting the dents and scratches, right? So it will auto detect that and it will use it in the model. So that is where the ANN or the deep models, like the deep neural network models, they excel as compared to the traditional models, right? And these models have been around for a long time. So the artificial neural networks, if you go back, they were there even in the 1900s, right? And the
Right.
reason now there is so much of use of these models as compared to the traditional models is because these models basically are computationally heavy. So even the data which is used here, which is videos or images, it's more difficult to store and it's more expensive to store than the normal data, right? But now with so much advances happening in the field of cloud computing and cloud storage, these processes have become really cheap and faster. So both they are both time and cost efficient. So that's why now people are finding using neural networks much more affordable, and that's why they are being used much more than the traditional machine learning model nowadays.
Right. So, you have mentioned, or rather quoted the example of auto insurance sector. So I believe, this something, it would certainly improve any sort of auto claims process as well, and saves a lot of time, money, both for the insurer as well as the insurance company.
Definitely, definitely. I think traditionally the way things used to happen is once the claim is made, then there's an agent which goes and inspects the car, looks at the damage which is there, submits a report, and then the claims get processed. So that's quite a
Right.
long process. But with image, you can really, one thing is you can speed up the process, of course,
Yeah.
because with simple cases, yes, with complicated, you cannot replace human intelligence. But at least with the simple cases, or at least the basic checks with the help of images, if it can be done,
Hmm.
it will definitely, one, speed up the process, and on the other hand, it will also help reduce the fraud cases, matching the description of the accident, say, with the kind of impact that has been there on the car, right?
Right.
So
Right.
that doing this kind of analysis, or using in both cases. So for the description, you can use text analytics and try to find what kind of accident has happened, and using image classification or image analytics, you can actually match that with the damage happened to the car, and you can actually detect fraudulent claims as well.
True. True. Yeah, I think that's certainly a game changer for the insurance sector, especially when the entire industry globally, if you look at the foremost challenge that they face is on fraudulent claims, and that's
Yes.
something we are trying to look at various solutions on how to address this situation. And now moving on to on one of the following questions. So how do you think artificial neural networks can help insurance companies to improve on persistency and predictability? I think this is one of the key elements of this, solution when we talk about any sort of insurance main challenges.
Yes, definitely. So I think for improving and for recognizing the challenges the company is facing in terms of persistency, it is important to know how happy and satisfied your customer is with your
Hmm.
company, right? And as I
Yeah.
mentioned earlier, feedback today is coming in different ways. So because of social media, you have feedback coming from different platforms, and while it has become very easy for the companies to reach out to the customers and get this kind of feedback, analyzing this feedback is equally more difficult because it's coming in different formats. And most of the feedback, whether it comes in form of audio or text, finally you have a bunch of free text that you need to extract information from. And there is a whole field in data science which deals with
Right.
this, which is called as text analytics, right?
Right.
And artificial neural networks today are playing a huge part in this field. So, just to give a certain examples of how the neural networks can help with text analytics is, one thing is topic modeling. So you have customer emails coming in huge quantities every day, and if you delay in responding to the customer, or if there is a slack in getting back to the customer, that finally affects the customer sentiment, and that has a direct impact on your persistency as well,
Yeah.
right?
Yeah.
So what topic modeling can help you do is it can help you segregate your emails in a very automated way. So if the customers are asking about their claim status, those emails can maybe automatically go directly to the claims department. Or if they are
Right.
asking about some new product, there's an opportunity for cross sell and upsell there, which you can actually tap on time, right? Or
Yeah.
say, if they are complaining, say, about mis-selling, or something like that, you can address these emails on priority. Neural networks today are even capable of judging the urgency, and even there are some very new and novel models being developed which can even go ahead and identify sarcasm. which is actually a
Interesting.
very, yeah, this is a very, till today, it was difficult for machine learning models to understand sarcasm. It was something that only a human being can identify very easily. But today, artificial neural networks have made good strides in that area as well, and they're capable of understanding how urgent the customer wants his, how urgent is the customer's email. Like if he is really threatening to escalate the complaint, or maybe
Hmm.
planning to take legal action, then that needs to be addressed on priority. So
True.
these are, this is something which artificial neural networks can help in. And yeah, so earlier we talked about image. So there, you have a field of artificial neural networks which are called as CNN, convolutional neural networks, which specialize in image classification. So similarly, here for text, you have something called as recurrent neural networks, which look at text as a sequence of words. So these neural networks actually specialize in dealing with sequences. So they work very well with things like music or text, which makes sense in a sequence. So even in a text, if you take any word individually, it will have a different meaning than when you look at it in the context of a sentence.
Hmm.
So a simple word like pretty, it's a pretty good word, I'll say, right?
Right.
But if you use it in a sentence like I'm pretty mad about the kind of service I'm receiving at your company, suddenly the entire context and the sentiment of the word has changed because of the word that has come after it, right?
True.
So these kind of neural network, which is the recurrent neural networks, are very good in identifying which words are important in the sentence from sentiment point of view and how they are impacting each other.
Yeah.
So even earlier traditional machine learning models are also there, like naive Bayes is there, SVM are there, which work well with text data. But I'll say neural networks have taken it to an entirely new level. So earlier with text, even 80% accuracy was considered as good enough accuracy with text data. But with artificial neural networks today, if you go on some open source competitions, you will see people are competing in the region of 99.8, 99.9% accuracy, which is like near human capacity of understanding emotions and sentiment. So I
Yeah.
think, I think there the neural networks can really help companies, understand their customer emotions, and help with the persistency. And as earlier we said, if they are going to, if they use these kind of models in claims processing, that it definitely has a very good impact on the customer sentiment. If there has been a claim, so there has been an event of loss for the customer. So if the companies actually go out and help in time while taking care of their risk, the risk related to frauds, and while mitigating that, if they speed up the process of reaching out to the customer, I think even that has a very pretty good effect on the
True.
persistency.
True. I know. I mean, when we talk about persistency, you know, in the insurance sector, especially in India, if I look at, I think the
Yeah.
persistency ratio makes a lot of significance for the industry. I mean, it really would define how an insurer would build a robust relation with their, policy buyers, for example. So it really depends, how you build the relation, and how you keep your buyers on your product purchaser list, whether they're in case of renewals or new prospects. And in India, if you know, there's a huge trust issue when we say insurance
Yes.
products. So people really do not understand the purpose behind the insurance product. It is not just a tax savings tool, right?
Hmm.
It's
Yeah.
primarily a risk mitigation tool, but we definitely do not understand for the past reasons and history that we have come across, and how I think you have explained very well how the artificial neural networks is actually giving or opening doors for the industry to actually look at various avenues on how to deal with customers. Because when you also mentioned claims, so that's
Yes.
that's particularly, as we say, the moment of truth in insurance,
Yes.
right? So it's I think it's a brilliant discovery that's happened, and of course, you guys are really giving it a direction for the sector to explore. Uh, Niraja, just moving on to a last discussion point. Uh,
Yes.
what do you think are the current developments that's happening in the world of artificial neural networks? That can actually be beneficial for the insurance sector.
Yes. So, as I said, while the artificial neural networks have been around for a long time, recently there has been a lot of research in this area because all of a sudden, because of technological developments, it has become very affordable with respect to time
Right.
and with respect to cost, right?
So,
But while those two problems have been solved, there is one very important prerequisite for these kind of models to work well, and that is data. So these are very data hungry models, and
mhm,
when we use these models in our at work, we realize that the more data we have and the more diverse data we have, the better the model is, right? But when you look at the industry today, there are many companies which have come up recently, which are newer companies, or they might be old companies, but they have started looking at data recently. So they have started building data warehouses or data lakes recently. So they don't
right.
have that kind of data which goes back, in time, or which is rich in terms of the variety, not just the volume. It needs to have variety as well. So that kind of data is not available with all the players in the industry. And if this power of data and this power of modeling is restricted only to the big players, then it won't really help the industry. It has to reach even the smallest of the players and the newest of the players. And with
True.
with that point of view, one of the most important and significant developments which I think which has happened in the in some of the recent years is transfer learning. So,
Mhm,
what transfer learning is when you build a model for one specific purpose and then you use it for some other purpose, right? And transfer learning works really well with artificial neural networks because of the way artificial neural networks are structured. So, just to give a very broad idea of what the architecture of neural networks is it that model is built in layers. So there are multiple layers in the model, and while the earlier layers solve more of the generic, they I'll say recognize more of the generic patterns, the later or the deeper layers go into the really intricate patterns, and they look at it with the context of the problem we are trying to predict. So just to give an example, we talked about detecting dents and scratches on cars, right? So
right.
if I built a CNN, the convolutional neural network, on top of that, what the initial layers will do is they'll probably just recognize the horizontal and the vertical lines in the picture. The middle layers will probably start recognizing the shape of a car. It will recognize that there is a car in the picture. And the later layers will actually go and look at the problem in hand, and it will actually detect the scratch or the dent, right? So if I look at this problem, then I realize that I don't really need just the car images or the damaged car images for the whole problem. The earlier two kind of layers I talked about, I can use the images which are already there, maybe freely available on internet, and that can be my data for detecting a car in an image, right? So I need not have a repository of images. There might be some open source images that are available. Okay, then why just stop at just images? There are companies who have huge data, who are now building models on top of these on top of either the data they have or this kind of open source data, and they're coming up with pre-trained models available. Okay, so one of the example is Google. So we talked about sentiment analysis, right? So recognizing sentiment is a function of English language more than of insurance industry, right? So there are certain nuances, something like say the premium is rising.
Mhm.
So this needs a context of insurance, right? But a simple sentence like "I am unhappy about the service" that doesn't really need a context of insurance. So the earlier layers in the model can work well with any kind of English data. It really doesn't need insurance data, or it doesn't really need data of your customers. Then what you can do is, so for example, Google has a model called as BERT, right? And since 2018, it is open source. Anybody can take it. So a student, a new company, a well-established company, anybody can take the model and it
Mhm.
can use it for its earlier generic layers. And then the top and the deeper layers, it can then build on its own data to give it more, to make it more specific to your data. So then you do out of, say, if you are building a model with 10 layers, you can have 8 layers which are well prepared by Google, who has a lot of data, and the last 2 layers you can build on your data, which is really specific to your data and your industry, right? So I
Right.
think transfer learning, because the way that artificial neural networks are structured, transfer learning can work really well with it, and I really like this because it opens doors to a lot of people today who don't have data at hand. They might have technology, but they don't have data. But nonetheless, they can use this kind of open source models, and they can really leverage the power of data in their company.
True. I think, I mean, it's a quite a heavy thought leadership that has come out today on artificial neural networks and the impact on insurance. I think not just customer experience, even pricing and risk management, that also has to do a lot when we say artificial neural networks and its benefits. So I'm sure people in the sector are certainly going to explore this, and I've come across your beautifully authored blog on this particular topic published by Aureus Analytics. You have clearly mentioned and differentiated on how it differs from the traditional way of modeling and the usage of artificial neural networks, and what's the difference, how it's actually benefiting the industry, and particularly the growth in unstructured data. I think that's going to be a massive issue for the insurance sector. Fantastic thoughts, Niraja. Thank you very much for your time for this lovely discussion and sharing your thoughts today. It was truly a delight to have you as our guest. And lastly, to wrap this up, thank you for listening and see you at our next episode. Take care and stay safe. Goodbye for now.